My dear students, welcome back to our channel. In this video, I will be explaining the B.Ed 4th semester subject Research Methods and Basic Statistics as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 3 first important short question is: what are the types of variables in statistics? Types of variables in statistics. In statistics, a variable is anything that can change or take different values. For example, age, height, marks, or income are variables because they vary from person to person. Types of variables. 1. Qualitative, categorical variables. These describe categories or qualities, not numbers. Example: gender, male, female, blood group, A, B, O, AB. 2. Quantitative, numerical variables. These are measured in numbers. 2 types. Discrete variables, whole numbers only. Example: number of siblings, 1, 2, 3. Continuous variables can take any value in decimals. Example: height, 160.5 centimeters, 170.2 centimeters. 3. Dependent and independent variables. Independent variable, the factor you change. Dependent variable, the result you measure. Example: in a study on study hours versus marks, study hours is equal to independent, marks is equal to dependent. In short, variables are like ingredients in a recipe. Some describe qualities, some are numbers, and some cause changes while others show results. Next important short question is: 2. Define type I and type 2 error. Type I and type 2 error. In statistics, when we test a hypothesis, we may sometimes make wrong decisions. These mistakes are called type I and type 2 errors. 1. Type I error, false positive. This happens when we reject a true hypothesis. In simple words, we think something is happening, but actually it is not. Example: a medical test shows a person has COVID, but in reality they don't. 2. Type 2 error, false negative. This happens when we accept a false hypothesis. In simple words, we fail to see something that actually exists. Example: a test shows a person is healthy, but actually they do have COVID. Easy way to remember. Type I error is equal to crying wolf when there is no wolf. Type 2 error is equal to not seeing the wolf when it is actually there. In short, type I is equal to rejecting truth, type 2 is equal to accepting falsehood. Next important short question is: 3. What is a normal distribution? Normal distribution. A normal distribution is a common way in statistics to show how data is spread. It is also called the bell-shaped curve because the graph looks like a bell. In this distribution, most values lie near the average, mean, and fewer values are found as we move far away from the mean. It is symmetrical, the left and right sides of the curve look the same. Mean is equal to median is equal to mode in a perfect normal distribution. Example: if we measure the heights of students in a class, most students will be around the average height, say 165 centimeters. Very few students will be very short or very tall. When plotted on a graph, the heights will form a bell-shaped curve. Easy to remember. Think of exam marks in a large class. Many students score around the average, while only a few get very high or very low marks. In short, a normal distribution shows data clustering around the mean in a bell-shaped, symmetrical curve. Next important short question is: 4. What is meant by rank correlation? Rank correlation. Rank correlation is a statistical method used to find the relationship between two sets of rankings. Instead of using actual numbers, it compares the order or position, rank, of values. It tells us whether two variables move in the same direction, positive, or in opposite directions, negative. Positive rank correlation: if a student ranks high in maths, they also rank high in science. Negative rank correlation: if a student ranks high in maths, they rank low in science. The most common formula is Spearman's rank correlation, which measures how closely two rankings are related. Example: suppose 5 students are ranked in sports and studies. If the students who are good at sports are also good in studies, the rank correlation will be high and positive. If the rankings are very different, correlation will be low or negative. In short, rank correlation shows the degree of agreement or disagreement between two rankings. Next important short question is: 5. Mention any two non-parametric tests. Two non-parametric tests. Non-parametric tests are statistical tests used when data does not follow normal distribution or when the sample size is small. These tests work on ranks, signs, or order instead of exact numbers. 1. Chi-square test, chi-superscript 2 test. It checks whether there is a significant relationship between two categorical variables. Example: a shopkeeper wants to know if people's choice of cold drink, Pepsi or Coke, depends on their age group. Using a chi-square test, he can check if the preference is linked to age or not. 2. Mann-Whitney test. It is used to compare differences between two independent groups when data is not normally distributed. Example: a teacher wants to compare the performance of boys and girls in a test, but marks are not normally distributed. Instead of a t-test, she can use the Mann-Whitney test. In short, non-parametric tests are useful when data is not normal, small, or in ranks. Next, Unit 3. Long questions. First important long question is: 1. Explain the measures of central tendency and measures of variation with examples. Measures of central tendency and measures of variation. In statistics, we often collect large amounts of data. To understand it easily, we need two important tools. 1. Measures of central tendency show the average value. 2. Measures of variation show how spread out the data is. 1. Measures of central tendency. These tell us the central or typical value in a dataset. The three main types are: mean, average. Add all values and divide by the number of values. Example: marks of 5 students is equal to 10, 20, 30, 40, 50. Mean is equal to 10 plus 20 plus 30 plus 40 plus 50 divided by 5 is equal to 30. Median. The middle value when numbers are arranged in order. Example: 10, 20, 30, 40, 50. Median is equal to 30. Mode. The value that occurs most often. Example: 5, 6, 6, 7, 8. Mode is equal to 6. Central tendency helps us know the typical performance, like the average marks in a class. 2. Measures of variation. These tell us how much the data values differ from each other. Range. Difference between the highest and lowest value. Example: in marks 10, 20, 30, 40, 50. Range is equal to 50 to 10 is equal to 40. Variance. It shows how far the values are from the mean, average. Larger variance means more spread. Standard deviation, SD. It is the square root of variance. It is easier to understand because it is in the same unit as data. Example, if average marks are 50 and SD is 5, most students' marks lie between 45 to 55. Quartile deviation shows variation in the middle 50% of the data. Useful when extreme values are present. Measures of variation show whether students' marks are very close to each other or widely spread. Conclusion. Central tendency is equal to typical value mean, median, mode. Variation is equal to spread of data range, variance, SD. Example. If two classes have the same average marks, say 60, but one class has SD is equal to 5 and another SD is equal to 20, the first class has more consistent performance. Next important long question is to discuss the concept of hypothesis, types of hypotheses, and the steps in hypothesis testing. Hypothesis, its types, and steps in hypothesis testing. 1. Concept of hypothesis. A hypothesis is a guess or assumption that a researcher makes about the relationship between two or more variables. It is like a prediction that can be tested using data. Example, a teacher thinks students who study daily score higher than students who study only before exams. This assumption is a hypothesis. 2. Types of hypotheses. 1. Null hypothesis, H. States that there is no difference or no relationship. Example, there is no difference in marks between daily learners and last-minute learners. 2. Alternative hypothesis, H. Opposite of null hypothesis. It states that a difference or relationship does exist. Example, daily learners score higher than last-minute learners. Other subtypes. Directional hypothesis predicts specific direction, e.g. Group A will score higher than Group B. Non-directional hypothesis predicts difference, but not the direction, example, there will be a difference in scores. 3. Steps in hypothesis testing. 1. Formulate hypotheses. Write null hypothesis, H, and alternative hypothesis, H. 2. Select significance level, alpha. Common levels are 5%, 0.05, or 1%, 0.01. It means the probability of making a mistake in rejecting H. 3. Choose a suitable test. Depending on data t-test, chi-square test, ANOVA, etc. 4. Collect data and calculate test value. Use formulas or statistical software to calculate. 5. Make decision, accept, reject H. Compare calculated value with table value, critical value. If calculated table value reject H, else accept H. 4. Example. Suppose a new teaching method is introduced. H. There is no difference in student marks using new and old methods. H. Students taught with the new method score better. After testing, if results are significant, we reject H and accept H. Conclusion. A hypothesis is a testable assumption. Two main types null, H, and alternative, H. Steps in hypothesis testing ensure scientific and logical conclusions. Easy tip. Always remember H is equal to no effect, H is equal to some effect. Next important long question is 3. Describe the applications and characteristics of normal distribution in educational research. Normal distribution, applications, and characteristics in educational research. 1. Meaning of normal distribution. A normal distribution is a bell-shaped curve in statistics. Most of the values are around the average, mean, and fewer values are at the extremes, very high or very low. Example, if we measure the heights of 1000 students, most will be close to the average height, say 160 centimeters, while very tall and very short students will be fewer. 2 characteristics of normal distribution. 1. Bell-shaped curve. Symmetrical around the mean. Left and right sides are mirror images. 2. Mean is equal to median is equal to mode. All 3 measures of central tendency are equal in a normal curve. 3. Symmetry. 50% of the data lies on each side of the mean. 4. Spread of data, standard deviation. About 68% of values lie within 1 SD. 95% within 2 SD. 99.7% within 3 SD. Example. If average exam marks are 60 with SD is equal to 10, then 68% of students will score between 50 and 70. 3. Applications of normal distribution in educational research. 1. Student performance analysis. Helps to see how students are spread around average marks in exams. Example, comparing performance of 2 classes. 2. Grading and evaluation. Teachers often use normal distribution for grading on a curve. Example, top 10% may get A, middle 60% BC, and lowest 10% DE. 3. Selection and admission tests. Entrance exams, like QET, NEET, G, assume scores follow normal distribution for cutoff marks. 4. Standardized tests. IQ tests and aptitude tests are designed to fit normal distribution. 5. Decision-making in research. Many statistical tests, t-test, z-test, ANOVA, are based on the assumption of normal distribution. 4. Conclusion. Normal distribution is like the natural law of averages. It is bell-shaped, symmetrical, and predictable. In education, it helps in evaluating marks, grading students, designing tests, and making fair decisions. Easy tip, remember 68-95-99.7 rule to quickly recall how data spreads in a normal distribution. Next important long question is 4. Explain the types and applications of t-tests in educational research. Types and applications of t-tests in educational research. 1. Meaning of t-test. A t-test is a statistical test used to check whether there is a significant difference between the means, averages, of 2 groups or between a sample mean and a population mean. In simple words, it helps teachers and researchers find out if differences in scores are real or just by chance. 2 types of t-tests. 1. One-sample t-test. Compares the mean of one group with a known value, like population mean. Example, if the average IQ in India is 100, and a teacher wants to see if her class average of 105 is significantly higher. 2. Independent samples t-test. Compares the means of 2 independent groups. Example, comparing average marks of boys and girls in a mathematics exam. 3. Paired sample t-test, dependent t-test. Compares means of the same group at 2 different times. Example, testing students before and after a special coaching program to see if their scores improved. 3. Applications of t-tests in educational research. 1. Comparing performance of groups. To check if one teaching method is better than another. Example, online learning versus classroom learning. 2. Evaluating effectiveness of interventions. Used to see if new teaching techniques, study materials, or training programs improve student results. Example, pre-test versus post-test marks after a skill development program. 3. Checking gender or regional differences. Helps to see if differences in scores are due to gender, rural-urban background, or socioeconomic status. 4. Validating research hypotheses. Many research studies in education use t-tests to prove or disprove assumptions. 4. Conclusion. The t-test is a simple but powerful tool in educational research. One sample t-test compares with a standard. Independent t-test compares to separate groups. Paired t-test compares the same group before and after treatment. Easy tip: remember 1 standard, 2 groups, paired, same students twice to recall the types quickly. Next important long question is 5. What is analysis of variance, ANOVA? Explain one-way and two-way ANOVA with examples. Analysis of variance, ANOVA. 1. Meaning. Analysis of variance, ANOVA, is a statistical test used to check whether the means of 3 or more groups are significantly different from each other. In simple words, while a t-test compares to groups, ANOVA is used when we want to compare more than 2 groups at the same time. 2. Why ANOVA is needed. If we test multiple groups using many t-tests, the chances of error increase. ANOVA solves this by testing all groups together in one test. 3 types of ANOVA. A. One-way ANOVA. Used when we compare the means of one factor, independent variable, across 3 or more groups. Example: a teacher wants to check if the average marks of students differ across 3 teaching methods: lecture method, group discussion, and online learning. Here, the factor is equal to teaching method and groups is equal to 3 methods. If ANOVA shows significant difference, it means at least one method works differently from others. B. Two-way ANOVA. Used when we study the effect of 2 factors at the same time. Example: a researcher wants to see how teaching method, lecture, online, group discussion, and gender, boys, girls, together affect exam performance. Here, 2 factors. 1. Teaching method. 2. Gender. Two-way ANOVA helps to know 1. Effect of teaching method. 2. Effect of gender. 3. Whether the combination of method and gender affects performance. 4. Applications in educational research. Comparing the effectiveness of different teaching strategies. Studying performance differences based on background, rural, urban, government, private schools. Evaluating multiple variables, like subject interest plus gender, together. 5. Conclusion. T-test is equal to compare 2 groups. ANOVA is equal to compare 3 or more groups. One-way ANOVA 1 factor, many groups. Two-way ANOVA 2 factors, multiple groups. Easy tip. One-way is equal to 1 reason, factor. Two-way is equal to 2 reasons, factors. This makes ANOVA a very useful tool in educational research.